Hey, this is Sleeper, and we are continuing with part 2 of the web requests module. Let's go ahead and get started with HTTP methods and codes. So HTTP supports multiple methods for accessing a resource. In the HTTP protocol, several request methods allow the browser to send information, forms, or files to the server. These methods are used, among other things, to tell the server how to process the request we send and how to reply. We saw different HTTP methods used in the HTTP requests we tested in the previous sections. With curl, if we use the -v to preview the full request, the first line contains the HTTP method. For example, the get / HTTP version 1.1. While with the browser dev tools, the HTTP method is shown in the method column. Furthermore, the response headers also contain the HTTP response code, which states the status of processing our HTTP request. So the HTTP request methods. The following are some of the commonly used methods. So the get method requests a specific resource. Additional data can be passed to the server via query strings in the URL. For example, $param equals value. The post method sends data to the server. It can handle multiple types of input, such as text, PDFs, and other forms of binary data. This data is appended in the request body present after the headers. The post method is commonly used when sending information, for example, forms or logins, or uploading data to a website such as documents or images. The head method requests the headers that would be returned if a GET request was made to the server. It doesn't return the request body and is usually made to check the response length before downloading resources. Put creates new resources on the server. Allowing this method without proper controls can lead to uploading malicious resources. Delete deletes an existing resource on the web server. If not properly secured, can lead to denial of service, a DOS, by deleting critical files on the web server. Options returns information about the server, such as the methods accepted by it, and the patch method applies partial modifications to the resource at the specified location. The list only highlights a few of the most commonly used HTTP methods. The availability of a particular method depends on the server as well as the application configuration. For a full list of HTTP methods, you can visit this link. Note: most modern web applications mainly rely on GET and POST methods. However, any web application that utilizes REST APIs also rely on PUT and DELETE, which are used to update and delete data on the API endpoint, respectively. Refer to the Introduction to Web Applications module for more details. So our response codes. HTTP status codes are used to tell the client the status of their request. An HTTP server can return 5 types of response codes. Type 1XX provides information and does not affect the processing of the request. 2XX returned when a request succeeds. The 300 returns when the server redirects the client. 400 signifies improper requests from the client, for example, requesting a resource that doesn't exist or requesting a bad format. And the 500s returned when there is some problem with the HTTP server itself. The following are some of the commonly seen examples from each of the above HTTP method types. So the code 200 OK returned on a successful request, and the response body usually contains the requested resource. 302 found redirects the client to another URL, for example, redirecting the user to their dashboard after a successful login. 400 bad request returned on encountering malformed requests such as requests with missing line terminators. 403 forbidden signifies that the client doesn't have appropriate access to the resource. It can also be returned when the server detects malicious input from the user. 404 not found, return when the client requests a resource that doesn't exist on the server. And the 500 internal server error, returned when the server cannot process the request. For a full list of standard HTTP response codes, you can visit this link. Apart from the standard HTTP codes, various servers and providers such as Cloudflare or AWS implement their own codes. GET. Whenever we visit any URL, our browsers default to a GET request to obtain the remote resources hosted at that URL. Once the browser receives the initial page it is requesting, it may send other requests using various HTTP methods. This can be observed through the Network tab in the browser DevTools, as seen in the previous section. Exercise. Pick any website of your choosing and monitor the Network tab in the browser DevTools as you visit it to understand what the page is performing. This technique can be used to thoroughly understand how a web application interacts with its backend, which can be an essential exercise for any web application assessment or bug bounty exercise. HTTP Basic Auth. When we visit the exercise found at the end of this section, it prompts us to enter a username and a password. Unlike the usual login forms, which utilize HTTP parameters to validate the user credentials, for example, post request, this type of authentication utilizes a basic HTTP authentication, which is handled directly by the web server to protect a specific page/directory without directly interacting with the web application. To access the page, we have to enter a valid pair of credentials, which are admin in this case. Once we enter the credentials, we would get access to the page. Let's try to access the page with curl, and we'll add the -I flag to view the response headers. So curl /i or -I. And as we see, we get the access denied and the response body. And we also get the basic realm is access denied and the web www authenticate header, which confirms that this page indeed uses basic HTTP auth, as discussed in the headers section. To provide the credentials through curl, we can use the -u flag as follows. So curl -u admin :admin. And then this time we do get the page in the response. There's another method we can provide the basic HTTP auth credentials, which is directly through the URL as username :password @URL, as we discussed in the first section. If we try the same with curl or our browser, we do get access to the page as well. So curl HTTP ://admin :admin at the server and port, we get the same response. We may also try visiting the same URL on a browser, and we should get authenticated as well. Exercise. Try to view the response headers by adding the -I flag to the above request, and see how an authenticated response differs from an unauthenticated one. So the -I views the response headers. Okay. The HTTP authorization header, if we add the -v flag to either of our earlier curl commands, it's our verbose, so we get to see everything here. As we are using basic HTTP auth, we can see that our HTTP request sets the authorization header to basic with that string equals, which is the base64 encoded value of admin. If we were using a modern method of authentication, for example, JWT, the authorization would be of type bearer and would contain a longer encrypted token. Let's try to manually set the authorization without supplying the credentials to see if it does allow us access to the page. We can set the header with the -h flag, and we'll use the same value from the above HTTP request. We can add the -h flag multiple times to specify multiple headers. As we can see, this also gave us access to the page. These are a few methods we can use to authenticate to the page. Most modern web applications use login forms built with the backend scripting language, for example PHP, which utilize HTTP post requests to authenticate the users and then return a code to maintain their authentication. Get parameters. Once we are authenticated, we get access to a city search function, in which we can enter a search term and get a list of matching cities. As the page returns our results, it may be contacting a remote resource to obtain the information and then display them on the page. To verify this, we can open the browser DevTools and go to the Network tab, or use the shortcut Control-Shift-E to get to the same tab. Before we enter our search term and view the requests, we may need to click on the trash icon in the top left to ensure we clear out any previous requests and only monitor newer requests. After that, we can enter any search term and hit enter, and we will immediately notice a new request being sent to the backend. When we click on the request, it gets sent to search.php with the get parameter search equals LE used in the URL. This helps us understand that the search function requests another page for the results. Now we can send the same request directly to search.php to get the full search results, though it will probably return them in a specific format, for example JSON, without having the HTML layouts shown in the above screenshots. To send a GET request with curl, we can use the exact same URL seen in the above screenshots, since GET requests place their parameters in the URL. However, browser DevTools provide a more convenient method of obtaining the curl command. We can right-click on the request and select Copy as curl. Then we can paste the copied command in our terminal and execute it, and we should get this exact same response. So curl with the URL and the header authorization specified, we get the results returned. Note, the copied command will contain all headers used in the HTTP request. However, we can remove most of them and only keep necessary authentication headers like the authorization header. We can also repeat the exact request right within the browser DevTools by selecting Copy and then Copy as Fetch. This will copy the same HTTP request using the JavaScript fetch library. Then we can go to the JavaScript console tab by clicking Control-Shift-K, paste our fetch command, and hit enter to send the request. As we see, the browser sent our request, and we can see the response returned after that. We can click on the response to view its details, expand various details, and read them. So it looks like we're going to have a question down below. We'll start the instance. We'll spawn the target. The exercise above seems to be broken as it returns incorrect results. Use the browser dev tools to see what is the request. Use the browser dev tools to see what is the request it is sending when we search, and use curl to search for flag and obtain the flag. So let's copy this. Our credentials here, admin. I'm going to use Edge so it's a little bigger so you can see it. So admin, and it said Control Shift, if I can remember, E. Where was that? Control Shift E. So I'll try it. Control Shift E. Okay, that doesn't look right. We'll do I first. Okay. Oh, there it is. Okay. So we'll sign in. We don't need to remember that. Okay. So jumping back, it's asking us, the exercise above seems to be broken as it returns incorrect results. Use the browser dev tools to see what the request it is sending when we search, and use curl to search for flag and obtain the flag. So it's asking us to find the request with the search.php and then copy that and curl that. So it's going to ask us to curl, right click, copy as curl. We'll try that. So jumping over, city search, where is our request? So I'm just looking through there. Is it asking us a specific search, or is it just asking us to curl for flag? Let's just try to search for flag in the city search and see what happens. So I think what it wants is this exact thing. Use curl to search for flag and obtain the flag. So we'll maybe try to copy this here. Jumping back, when it says to right click, copy as curl, where is it? Oh, on the request itself. So let's try that. So copy as curl command. And I'll need the command line now. So I'll go ahead and open that. So paste. It's saying we don't need much of this besides the authorization flag, so I'll just clear most of this out except for the authorization. And I'll go back some. I think that's far enough. Okay, so clear this out. And just about done, I think. We'll try it. It says access denied. Bad illegal format. Let's try it again here. Maybe those just says access denied. I think it's missing my header, so I'll try to copy this and then paste it here. There it is. Okay. So I think this caret messed it up. It kind of just deleted everything afterwards. But when I curled the request and then I pasted in the authorization and the basic, with the basic, the base 64, what's it called? Encoding. That's when it finally returned the flag. So there it is. Let's go ahead and copy it and paste that in. Incorrect answer. Oh. There we go. And carrying on. Alright, so the post. In the previous section, we saw how GET requests may be used by web applications for functionalities like search and accessing pages. However, whenever web applications need to transfer files or move the user parameters from the URL, they utilize POST requests. Unlike HTTP GET, which places user parameters within the URL, HTTP POST places user parameters within the HTTP request body. This has three main benefits. Lack of logging, as POST requests may transfer large files, for example, a file upload. It would not be efficient for the server to log all the uploaded files as part of the requested URL, as would be the case with a file uploaded through a GET request. Excuse me. Less encoding requirements. URLs are designed to be shared, which means they need to conform to characters that can be converted to letters. The POST request places data in the body which can accept binary data. The only characters that need to be encoded are those that are used to separate parameters. And lastly, more data can be sent. The maximum URL length varies between browsers, Chrome, Firefox, Internet Explorer, between web servers, IIS, Apache, Nginx, between content delivery networks, Fastly, CloudFront, Cloudflare, and even URL shorteners like bit.ly and Amazon amzn.to. Generally speaking, a URL's length should be kept to below 2,000 characters, and so they cannot handle a lot of data. So let's see some examples of how POST requests work and how we can utilize tools like curl or browser dev tools to read and send POST requests. Login forms. The exercise at the end of this section is similar to the example we saw in the GET section. However, once we visit the website, the web application, we see that it utilizes a PHP login form instead of a HTTP basic auth. If we try to log in with admin, we get in and see a similar search function to the one we saw earlier in the GET section. If we clear the network tab in our browser DevTools and try to log in again, we will see many requests being sent. We can filter the requests by our server IP, so it would only show requests going through the web application's web server. For example, filter out external requests, and we will notice the following POST request being sent. We can right-click on the request, click on the request tab, which shows the body, the request body, and then click on the raw button to show the raw request data. We see the following data is being sent as the post request data: code bash username equals admin and password equals admin. With the request data at hand, we can try to send a similar request with curl to see whether this would allow us to log in as well. Furthermore, as we did in the previous section, we can simply right-click on the request and select copy as curl. However, it is important to be able to craft post requests manually, so let's try to do so. We will use the $X post flag to send a post request. Then to add our post data, we can use the -D flag and add the above data after it as follows. So curl $X post D, username equals admin and password equals admin, and our web server and port number. If we examine the HTML code, we will not see the login form code, but we'll see the search function code, which indicates that we did indeed get authenticated. Tip: many login forms would redirect us to a different page once authenticated, for example, dashboard.php. If we want to follow the redirection with curl, we can use the $L flag. Authenticated cookies. If we were successfully authenticated, we should have received a cookie so our browsers can persist our authentication, and so we don't need to log in every time we visit the page. We can use the -V or the -I flags to view the response, which should contain the set cookie header with our authenticated cookie. So the -I flag, and there's our set cookie header. With our authenticated cookie, we should now be able to interact with the web application without needing to provide our credentials every time. To test this, we can set the above cookie with the -B flag and curl as follows. So curl -B with that authentication cookie. As we can see, we were indeed authenticated and got to the search function. It is also possible to specify the cookie as a header as follows. So the curl -H with a cookie header, PHP session ID is our authenticated cookie. We may also try to do the same thing with our browsers. Let's first log out, and then we should get back to the login page. Then we can go to the storage tab in the DevTools with Shift F9. In the storage tab, we can click on cookies in the left pane and select our website to view our current cookies. We may or may not have existing cookies, but if we were logged out, then our PHP cookie should not be authenticated, which is why if we get the login form and not the search function. Now, let's try to use our earlier authenticated cookie and see if we do get in without needing to provide our credentials. To do so, we can simply replace the cookie value with our own. Otherwise, we can right-click on the cookie and select Delete All, and then click on the plus icon to add a new cookie. After that, we need to enter the cookie name, which is the part before the equals PHP session ID, and then the cookie value, which is the part after the equal sign. Then, once our cookie is set, we can refresh the page, and we will see that we do indeed get authenticated without needing to log in, simply by using an authenticated cookie. As we can see, having a valid cookie may be enough to get authenticated into many web applications. This can be an essential part of some web attacks like cross-site scripting. JSON data. Finally, let's see what requests get sent when we interact with the city search function. To do so, we will go to the Network tab in the browser DevTools and then click on the trash icon to clear all requests. Then we can make any search query to see what requests we get. As we can see, the search form sends a post request to search.php with the following data. Our bracket, quote, search, quote, colon, quote, London, quote, bracket. The post data appears to be in JSON format, so our request must have specified the content type header to be application/JSON. We can confirm this by right-clicking on the request and selecting Copy Request Headers. Indeed, we do have content type application JSON. Let's try to replicate this request as we did earlier, but include both the cookie and content type headers, and send our request to search.php. So curl -x post -d with that JSON -b with our cookie, the content type application JSON, and our website. As we can see, we were able to interact with the search function directly without needing to log in or interact with the web application front end. This can be an essential skill when performing web application assessments or bug bounty exercises, as it is much faster to test web applications this way. Exercise. Trying to repeat the above request without adding the cookie or content type headers and see how the web app would act differently. So if we didn't add that cookie, it wouldn't work probably. It would get a 404 or something like that. Without the content type, it probably wouldn't register this as well. Finally, let's try to repeat the same above request by using fetch, as we did in the previous section. We can right-click on request and select copy as fetch, and then go to the console tab and execute our code there. Our request successfully returned the same data that we got with curl. Try to search for different cities by directly interacting with the search.php through fetch or curl. And we've got a question. We'll spawn the target. So we want to obtain a session cookie through a valid login, and then use the cookie with curl to search for the flag through a JSON post request to search.php. So let's go ahead and copy that. We'll load it into our Edge browser once again. And our requests, we've got our username admin. And our search, if we search for flag, nothing is there. So we want to copy as curl again. Bring that over to here. Our command line. I'll just clear this and paste. So I'm gonna clear out most of this again. We just want the cookie, the content type, and we'll see what happens. It asked for a post request, so we might need to modify that as well. Clear those out. Okay. Then bring this back all the way to the request. age, content type, JSON. I think that's okay. We'll verify up here real quick. Post, content type. So let's see. It's a little different. Content type. Okay, so we need our, let's just copy this. Oops. Okay, I'm here. I'm seeing double in this, so it's kind of hard to type. But we'll post this in, paste this in, and we're going to clear out London. We're going to put flag here. So we have our post request searching for flag at our website with the headers, the application, the content type, and the cookie that we need. So we will hit enter and see what happens. A valid authentication cookie is required. I think I can't see very well here, so I don't think it registered this one, so we'll just copy that again and paste it. And there we go. And that's our flag. We'll copy that and paste that in. So we needed curl with a post request searching for a flag at our website and our search function with the header of the application JSON and the cookie of our admin. I didn't do this before, but I will try it. This one. Copy as fetch and then paste it in to console. Let's try it. And hit enter. Promise. Promise fulfilled. Let's see. What's in this? If anything. Post include, search for flag. I think this looks okay, but where is the flag? Get body. Probably in here. I wonder if we can just filter for it. We already know what it is, so let's shortcut this. HTB. Oops. Nine hidden. Get body used. Let's see if we can look through here. Maybe network. Because let's see. PHP session. Payload, preview, response. No response. Well, that's what we saw before, so there's nothing here. It's asking us for the curl, so we're not going to get it unless we do it through curl. And our last section here, CRUD API, or CRUD. We saw examples of a city search web application that uses PHP parameters to search for a city name in the previous sections. This section will look at how such a web application may utilize APIs to perform the same thing, and we will directly interact with the API endpoint. APIs. There are several types of APIs. Many APIs are used to interact with a database such that we would be able to specify the requested table and, the requested row within our API query, and then use an HTTP method to perform the operation needed. For example, the API.php endpoint in our example, if we wanted to update the city table in the database and the row we will be updating has a name, city name of London, then the URL would look something like this. That was a mouthful. So we got curl-x put our API and then \city London. The rest is cut off. So acronym CRUD. As we can see, we can easily specify the table and the row we want to perform an operation on through such APIs. Grammar. Then we may utilize different HTTP requests to perform different operations on that row. In general, APIs perform 4 main operations on the requested database entity. Operation create, HTTP method post, adds the specified data to the database table. Read is the GET request, reads the specified entity from the database table. Update is the put method, updates the data of the specified database table. And delete is the same, delete removes the specified row from the database table. These 4 operations are mainly linked to the commonly known CRUD APIs, but the same principle is also used in REST APIs and several other types of APIs. Of course, not all APIs work in the same way, and the user access control will limit what actions we can perform and what results we can see. And the Introduction to Web Applications module, we will further explain these concepts, so you may refer to it for more details about APIs and their usage. So read, the first thing we will do when interacting with an API is reading data. As mentioned earlier, we can simply specify the table name after the API, example \city, and then specify our search term, for example \London, as follows. So we curl the web server import \API.php, and there's our \city/London. We can see that the results is sent as a JSON string. To have it properly formatted in JSON format, we can pipe the output to the JQ utility, which will format it properly. We will also silent any unneeded curl output with -s as follows. So the JQ puts it in the JSON format. -as silence any unnecessary output. As we can see, we got the output in nicely formatted output. We can also provide a search term and get all matching results. So it just did -le. It got everything containing le. Finally, we can pass an empty string to retrieve all entries in the table. So just /city, get everything there. Try visiting any of the above links using your browser to see what the result is rendered. See how the result is rendered. We have the create to add a new entry. We can use an HTTP post request, which is quite similar to what we have performed in the previous section. We can simply post our JSON data and it will be added to the table. As this API is using JSON data, we will also set the content type header to JSON as follows. So we're posting our JSON directory with the JSON data and the content type specifying JSON. Now we can read the content of the city we added. So HTTP hack the box city to see if it was successfully added. So we're curling in JSON format with the JQ utility / hack the box city, and it exists. So as we can see, a new city was created which did not exist before. Example, or exercise rather, try adding a new city through the browser dev tools by using one of the fetch post requests you used in the previous section. I'll try that in a minute. Update. Now that we know how to read and write entries through APIs, let's start discussing two other HTTP methods we have not used so far, put and delete. As mentioned at the beginning of this section, put is used to update API entries and modify their details, while delete is used to remove a specified entity. Note, the HTTP patch method may also be used to update API entries instead of put. To be precise, patch is used to partially update an entry, only modify some of its data, for example, only city_name, while put is used to update the entire entry. We may also use the HTTP options method to see which of the two is accepted by the server, and then use the appropriate method accordingly. In this section, we will be focusing on the put method, though their usage is quite similar. Using put is quite similar to post in this case, with the only difference being that we have to specify the name of the entity we want to edit in the URL. Otherwise, the API will not know which entity to edit. So all we have to do is specify the city, name, and the URL. Change the request method to put, and provide the JSON data like we did with post, as follows. So curl X, we're putting in our API in the London section, we're modifying this to put HTTP new hack the box city, country name, hack the box, with our content type being JSON. So we see in the example above that we first specified city London as our city and passed a JSON string that contained the city name new, hack the box city, in the request field. So the London city should no longer exist, and a new city with the name new hack the box city should exist. So we're trying to curl the city of London, and nothing comes up. Indeed, we successfully replaced the old city name with the new city, hack the box city. Note, in some APIs, the update operation may be used to create new entries as well. Basically, we would send our data, and if it does not exist, it would create it. For example, in the above example, even if an entry with a London city did not exist, it would create a new entry with the details we passed. In our example, however, this is not the case. Try to update a non-existing city and see what you get. And lastly, the delete. Finally, let's try to delete a city, which is as easy as reading a city. We simply specify the city name for the API and use the HTTP delete method, and it would delete the entry as follows. So we're curling $X delete our new hack the box city. We try to curl the new hack the box city, and nothing comes up. As we can see, after we deleted new hack the box city, we get an empty array when we try reading it, meaning it no longer exists. Exercise. Try to delete any of the cities you added earlier through post requests, then read all entries to confirm that they were successfully deleted. With this, we are able to perform all 4 CRUD operations through curl. In a real-world application, such actions may not be allowed for all users, or it would be considered a vulnerability if anyone could modify or delete any entry. Each user would have certain privileges on what they could read or write, where write refers to adding, modifying, or deleting data. To authenticate our user to use the API, we would need to pass a cookie or an authorization header, for example, JWT, as we did in an earlier section. Other than that, the operations are similar to what we practiced in this section. And we have a question here. So, an exercise. First, try to update any city's name to be flag. Then, delete any city. Once done, search for a city named flag to get the flag. So, let's go ahead and do that. We'll load it up over here in our other tab. It is loading. Let's try it again. Is there anything here? We might need to use curl. Okay, so it's saying try to update any city's name to be flag. So let's just copy one of these first. So we want to update. So they updated this here. So we'll update this one. We're going to put, if London exists, we'll just use the same name. So we'll paste that in and clear this because we don't need this. We'll grab our port number and IP address. Oh, it probably didn't load because we didn't do the API. So we can do that in a second after we paste this in. Okay. So API.php. Maybe at the end. Yeah. Incorrect table name. So we got to go through curl here. So we'll hit enter. Okay, so we curled it. It should be replaced if we try to paste that in now. Oh yeah. We'll do the same thing here. Clear this out. Grab our IP address and port number, paste that in, and clear out this intro part. Okay. So nothing's there. If we do the same thing for the new Hack the Box city, we have it there. It says please update any city's name to be flag. So we'll do that first one again, changing this one again. So new Hack the Box city. We're going to change that to, wait, not that one, put. Okay. We're going to change that to flag like it suggests. New city name flag. Country winners. And put new city, new Hack the Box city right here. Okay. So that's the first part. Update any city's name to be flag. So there we go. Let's do it. Boom. If we try to load it now, if we try to load flag, there's our flag. And then it's saying, once done, search for a city named flag to get the flag. So it says delete any city. So if I'm going to try to delete this. So just -x delete. So let's click this at the top, -x delete. See if that works. I can't see if I have a space. I think I should. And try to load it again. Nothing's there. So update any city's name to flag. Then delete any city. Once done, search for a city named flag to get the flag. So maybe without the JSON or without any flags. Let's just try this now. We did delete any city, technically. Maybe we need to delete the other one. Try to load it here. What's it? Control-Shift-E. That keeps happening. Control-Shift-I. Refresh this here. There's our request. Copy as curl. Come back over here. Let's try to just paste it as is. Okay, it doesn't like that at all. So let's just view. Oh yeah. It said if we have an empty city, we can look up all the names. So if we just do /city, here's all the names. Okay, so this is, I wonder if it's in this list here. Oh, in JSON format, what was it, JQ? That's good. So we are looking, I wonder if we can just grep. I think it doesn't want us to delete the flag city, so we'll do it with Baltimore. Goodbye, Baltimore. Here we go. Okay, so then if we query our flag, it showed, okay, there it goes. So it didn't want us to delete it. But there we go. So we grab our flag and paste that in. So we did things a little out of order there, but we did delete one, we did rename, we did update, we did delete, and then we did search for it. So there we go. Finish. Alright, so that's been the web requests module from the Bug Bounty Hunter job role path. Our next module up will be the Introduction to Web Applications. So thanks for tuning in to this. Once again, my name is Sleeper, and that's a wrap. Until next time.